Hello viewers, in today's session we are going to discuss a very important and conceptual problem from a range of functions. And in this session we are going to find out the range of this inverse trigonometric function, that is f of x is equal to tan inverse 2x minus x square, right? So here we'll see how we can find out the range of this function by using some concepts, right? So here let us first see the concepts which are going to be used to find out the range of this function. So now let us first take y is equal to f of x, that is tan inverse 2x minus x square, right? Now see, whenever we have a function, say y is equal to f of x, and this x is known as the independent variable and y is known as the dependent variable, then for all values of valid values of x, we have a corresponding value of y, right? So this y constitutes the range of the function f of x, and all valid values of x are known as the domain of the function, right? So this is the first thing. And then from inverse trigonometric functions, we know that the range of the function, that is tan inverse, is given by minus pi by 2 to pi by 2, right? And here we have the open interval. So this is the second thing. Now the third thing is that the function tan inverse is an increasing function, because if we differentiate tan inverse x, then the derivative of tan inverse x is 1 over 1 plus x square, and 1 over 1 plus x square is greater than 0 for all values of x belonging to the set of real numbers, right? So this tan inverse x is an increasing function. So these are the two important concepts which are going to be used to find out the range of this function. So now let us take this tan inverse y to this side. We can have tan y is equal to 2x minus x square. Now see, this 2x minus x square is a quadratic polynomial, right? And here what we will do, we'll try to convert this quadratic polynomial into a perfect square. So taking minus sign common here, we can now write x square minus 2x. So we can now write x square minus 2x, now adding 1 and subtracting 1. So now this trinomial, that is x square minus 2x plus 1, is equal to x minus 1 square, that is a minus b square. So we have a square plus b square minus 2ab, that is minus 2x. So now we can write here this term as x minus 1 square minus 1. So now multiplying here these two terms by this negative sign, we have minus x minus 1 square plus 1, right? So what we have done here, we have expressed tan y as minus x minus 1 square plus 1. So now let us move from this step, that is x minus 1 square. Now see, x minus 1 square is always going to be greater than 0 or equal to 0. For x is equal to 1, the equality holds, and for other values of x, x minus 1 square is always greater than 0 or it is positive, because this is a square term, right? Okay, now what we'll do, we'll multiply both sides by minus 1. So when we multiply both sides by minus 1, we have the reversed direction of the inequality. So we have minus x minus 1 square is less than or equal to 0. So when we multiply both sides of an inequality by a negative sign or negative number, then the direction of the inequality it gets flipped, right? Okay, now here we have 1. So adding both sides 1, we have 1 minus x minus 1 square, and here we have 0 plus 1, that is 1. Now see, this expression is 1 minus x minus 1 square. So 1 minus x minus 1 square is equal to tan y. So we have tan y less than or equal to 1, right? So this is an important inequality in connection to finding out the range of this function. So we have tan of y is less than or equal to 1. Now let us take tan inverse of both sides. So we have tan inverse, and here we have tan of y, and here we have tan inverse of 1. So what we have done here, we have taken tangent inverse of both sides. But here see, the direction of the inequality doesn't change, because this tan inverse x is an increasing function, right? So the inequality remains, the direction of the inequality remains the same. So here tan inverse tan y is simply y, and here tan inverse 1 is pi by 4, because we know that tan pi by 4, that is tan 45 degrees, is equal to 1. So pi by 4 is equal to tan inverse 1. And here from inverse trigonometric functions, we know that tan inverse of tan theta is equal to theta. So here we have y. So y is less than or equal to pi by 4. So now y is equal to tan inverse 2x minus x square. So we can also write tan inverse 2x minus x square is less than or equal to pi by 4. Right? Now see, here we have just discussed that the principal value branch of tan inverse is minus pi by 2 to pi by 2. So here we have minus pi by 2, and here we have pi by 2, right? And both these points are not included. So here we have y less than or equal to pi by 4. Now here y is less than or equal to pi by 4. So let us locate y is equal to pi by 4, and pi by 4 lies between minus pi by 2 and pi by 2. So pi by 4 it lies somewhere here, and here pi by 4 is included, because here y is equal to pi by 4 and less than pi by 4. So now this inequality, that is y less than or equal to pi by 4, it suggests that we have to consider only this interval, right? See, the principal value branch of tan inverse is from minus pi by 2 to pi by 2, and here we have obtained this inequality, that is y is less than or equal to pi by 4. So we have located pi by 4 in between minus pi by 2 and pi by 2, and y less than or equal to pi by 4 suggests that we have to consider only this interval, that is our y it belongs to the interval that is minus pi by 2, and here we have pi by 4, because here the equality sign holds, right? So y belongs to the interval which is open from left and closed from right. So y belongs to minus pi by 2 to pi by 4, and y is our function that is tan inverse 2x minus x square. So tan inverse 2x minus x square, it belongs to this interval that is from minus pi by 2 to pi by 4, and this is the range of this function tan inverse 2x minus x square. So viewers, this is how by making use of these concepts, that is principal value branch of tan inverse function, and then the increasing nature of the function tan inverse x, and some simple algebra, we can easily find out the range of these type of functions.